Today we are going to go over question 13 of exam 2 part 1. Question 13, 40 kilograms of saturated vapor water at 150 degrees Celsius is heated to 300 degrees Celsius in a rigid tank. Part A is to calculate the work in kilojoules for this process. Given that it is a rigid tank, the volume remains constant. This means that the work for this process is equal to 0. Part B is to calculate the heat transfer in kilojoules for this process. We have the equation for heat transfer, where Q is equal to delta U plus W. Remember, work is equal to 0, so we are left with Q equaling U2 minus U1. We can replace big U with little u times m, which is specific internal energy times mass. Our final equation for heat transfer is Q is equal to m times U2 minus U1. First, we will determine U1 at 150 degrees Celsius. Since the phase is saturated vapor, U1 is equal to Ug at 150 degrees Celsius. We can take a look at table C1 and locate a temperature of 150 degrees Celsius to determine Ug, which is 2,559.5 kilojoules over kilogram. Also, we will take a note that Vg is equal to 0.3928 meters cubed over kilogram. To determine U2, we will first draw a PV plot with our initial state. Our initial phase is saturated vapor with a temperature of 150 degrees Celsius and Vg is equal to 0.3928 meters cubed over kilogram. We will then draw our new temperature slice of 300 degrees Celsius. Since our volume remains the same, Vg will remain the same. And we will draw a straight line until it intersects our new temperature slice. It intersects in the superheated vapor section, meaning our new phase is superheated vapor. Taking a look at table C3 for superheated vapor, we will locate a specific volume close to our value. At a temperature of 300 degrees Celsius, our specific volume falls between 0.4344 and 0.3241. We will interpolate next to find U2. Plugging in our values, we find U2 is equal to 2,799.57 kilojoules over kilogram. From the previous step, we have U1 is equal to 2,559.5 kilojoules over kilogram. We now have all the values needed to plug into our equation. Q is equal to m times U2 minus U1, making our final Q to 1 to 2 is equal to 9,602.67 kilojoules.